some of the stuff that happened this summer. And then we're going to open it up for Q&A. But we did several webinars already, so I'm going to go over the background pretty quickly, and Greg's going to mostly focus on what's new. So if you have questions about other background or the website in general, maybe we will deal with those in the Q&A, or we can send you to one of our previous webinars. Next slide, please. Thanks. So the website itself was created because we were directed by Congress to do that in the Omnibus Act of 2018. And they specifically asked that the Forest Service produce a national map to help inform communities about their wildfire risk. So we took that both literally and figuratively. We realized that we could probably go a little bit farther than just making a map and putting it up on a website. So we have an interactive map, and we have delivered geospatial data sets so that the communities can download that data and use it to their own purposes for their own risk analysis if they want to. We also thought it was important that communities understand how risk is calculated and what are the components of risk. And we also thought it was important that we provide them with methods that they might be able to reduce that risk, or at least to begin thinking about that. So really this was intended to be a conversation starter, and our target audience was the community leaders. And the product was published in April of 2020, wildfirerisk.org, and it's searchable by communities, by counties, and by states. Next slide, please. So as I mentioned earlier, the Forest Service was assigned to be the lead in this project. So that's the Washington Office of Fire and Aviation. That's how Jim Menakis and I got involved. And it didn't take us very long, only a few seconds actually, to realize that it was more than we could do by ourselves. So we contacted Greg Dillon over at the Missoula Fire Lab in the Rocky Mountain Research Station to be a technical lead and a liaison to the rest of the research, and to start thinking about how we were going to pull this off. And it didn't take the three of us very long to realize that we were going to need some help with fire analysis and with data processing. And so we had a contract with Pyrologic, that's Joe Scott's company, and his team of incredibly smart people. And they agreed to help us process the data. And that might have been the second best decision we made. The first best decision came a little bit later, when we realized that in order for this website to really be useful, we needed to go beyond the typical government website and have some interactive features. And so we entered into a cooperative agreement with Headwaters Economics. And those folks have a long history of working with the Forest Service and producing websites and helping us communicate with our target audience of communities and community leaders. Next slide, please. But we didn't build this from the ground up. We were building, standing on the shoulders of others. And in two particular, I want to point out the Landfire. We couldn't have done this without Landfire data. It's really the only data set that's available nationwide. And our product is all 50 states. We used a Landfire 2014 data set. Landfire is currently working on a new data set that we call the Remap project, and have currently completed 49 out of 50 states. So pretty soon, by next year, we may have a full 50 state data set available to update this. But at the present time, it's the Landfire data that's circa 2014. The other one I want to point out is the Rocky Mountain Research Station. We relied heavily on the Large Fire Simulator, FSIM, developed by Mark Finney probably a decade ago, and the General Technical Report 315, also developed at the Rocky Mountain Research Station. 2013, I believe that came out. And so we had definitely, the hard work was done. We just had to pull the pieces together. But I like to think that we came up with a few innovations of our own. Next slide, please. So in taking a look at the data on the website, I want to highlight a few things and caution you about a few things. On the highlight side, we used nationally consistent data and risk metrics. So it's the same as best we could across the entire country. And the data is available nationwide to all 50 states, all counties, and all communities that were identified in the as a census designated place, about 30,000 of those. We're grounded in the best available science, as I mentioned on the last slide, using Landfire and GTR 315. I like to think that the website, the end product, is easy to use and includes useful resources for action targeted at those community leaders, things they can do once they realize that they may have a wildfire risk problem. However, on the other side, I have to caution users that this product is not fine scale. It wasn't developed with fine scale data, and it really does a better job of comparing community A with community B or county A with county B, rather than the differences within a community. Likewise, it's not locally calibrated. If we were doing a project for a particular community, we would work with the local folks and see what data they had and maybe incorporate some of that data to do a better job of predicting the variances and wildfire risk across the community. It's not predictive. It's not an indication of what the wildfire season in 2021 is going to be like. It's based on historic data, and it certainly does not include climate projections. Those are useful sciences that could be incorporated into other analysis, but they're not part of this. And perhaps most important, it's not a replacement for other wildfire risk assessments. There have been quite a few wildfire risk assessments done at different scales, regional, statewide, et cetera, across the country. In fact, there's a website that the National Association of State Foresters have put up called Has Explorer that allows you to enter a location in, and you can see what other risk assessments have been done. But this effort does not replace any of those because they all have their own objectives and their own data sources. And if you use those, just as if you use this, it's important to understand where that data comes from so that you can better apply it. And with that, on the next slide, I'm going to turn it over to Mr. Dillon, Dr. Dillon, I think.
All right, thanks. Well, that's an honorary doctorate there you just gave me, Frank. But thanks for that intro and background about the Wildfire Risk Communities Project. And so my task now is to show you all a little bit about some of the new features that we have on the website and some of the new data sets that we have coming for download very soon. Let's see, there we go. So in terms of new features, our website, look like most of you have at least visited it a little bit, is organized around these themes of understand, explore, and reduce risk. And so in the understand section, we have some enhanced content. It looks a little bit different. It's mostly the same information, but we've tried to fill in the gaps in a few places where we could and just enhance the navigation a little bit around the page. On the explore risk part of the website, we've added a feature that allows you to basically mask out just populated areas. And so I'll show that in a minute. In the reduce risk area, we have added some new links to different resources that we didn't have before and community tools, just trying to add to that toolbox of information and resources that local people can use to seek out ways they can take action. And then our download page on the website has also been enhanced, looks a little bit nicer, and soon we'll have quite a bit more data that you can access. So with that, I'm going to switch over to the website and we'll do a little bit of a live demo. So here's the homepage when you go to wildfirerisk.org. And right off the bat, I just wanted to point out that we have expanded our menu across the top to also include a download link. Before, to get to that download link, you had to be in the Explore tool. So this allows you sort of a direct line to get to the data download from the homepage. I'll just click into each one briefly. As I mentioned a minute ago, the Understand Risk part of the website has just some feature enhancements. I'll use this as an opportunity to remind folks. I think most of you may be at least somewhat familiar with how we present risk, but this little graphic really summarizes what goes into all of our data sets and how we conceptualize wildfire risk. And so it is a combination of hazard times vulnerability, and each of those has its own components. So hazard is made up of wildfire likelihood or burn probability. So that's just the likelihood of fire occurrence. the intensity that we would expect to see in a wildfire given the fuels and other conditions at any given place. So those come from fire modeling, the FSIM model that Frank mentioned a minute ago. And then the vulnerability side includes exposure, which is that overlap of a value at risk. In this case, we're talking about homes with where we have wildfire hazard. And the susceptibility, which gets at if wildfire encounters those homes, what is the outcome? How susceptible are those homes to being damaged by wildfire? So that's the foundation of everything that we do here. And this Understand Risk page goes through and allows you to learn more about each of those. From any of these pages, clicking on our main logo at the top will take you back home. And I'm going to jump over to the Reduce section quickly, and then we'll come back to Explore. So again, the Reduce Risk section is where people can learn about things they can do to take action in their own community. And we have these focused around themes like home ignition zone, home hardening, land use planning, wildfire preparedness, community health, wildfire prevention, wildfire response, fuel treatments, and post-fire recovery. And as I mentioned a few minutes ago, we've added some new resources into those. I'm not going to take the time to dive into each one now, but I encourage you to explore them. Then going back to the homepage, now I'll take us into the Explore part of the website, which is our interactive app. And the way this works is typing in a name of any community, state, or county. I'm going to start actually by typing in a community that's been in the news quite a bit this summer, Calistoga, California, which was impacted by the glass fire recently. So we come in and we're looking at our risk to homes view. We have 4 tabs across here that allow you to look at different data views. So risk to homes is what you start out in. And you have a little bit of a legend here. And I'm not sure, I'm gonna refresh because we should also, there we go. I don't know why that chart didn't come in the first time. So we have a map over here that shows us risk to homes divided into 5 categories. They're based on percentiles. When we search on a community or a county, the map is displaying those based on percentiles in the state that this community is located in. So that tells us this over on our legend that it's risk to homes in California. So we're relativized within the state of California. The colors in our scatter plot here correspond to the map. And we have communities plotted on 2 axes, which basically make up the risk to homes metric, wildfire likelihood. So that's that burn probability, and that's on a log scale. So orders of magnitude across the bottom here. And then the vertical axis is wildfire consequence. So that would be the combination of wildfire intensity with the susceptibility piece. How likely are homes to be damaged by fire at different intensities? And the homes with the highest risk have the highest combination, or the communities with highest risk have the highest combination of wildfire likelihood and wildfire consequence. So we can see Calistoga, we get a statistic that it's at the 56th percentile relative to other communities in the state of California. California is a state with a lot of very high risk communities, as you might imagine. So the one feature that is new here, all of what I've explained was in our April launch, but the feature that is new is this toggle that you see here. By default, this risk to homes map shows a value across the entire landscape, even in places where there aren't homes. So we can kind of understand, even if we were considering building new homes, we could compare what the relative risk in those places are to places that already have homes. What a lot of people want to be able to do is just see where we actually have housing density right now. And so when I clicked on that toggle, you can see it put up a transparent mask. I can still see through it a little bit, but it's basically masked out within the boundaries of the community of Calistoga. Where do we have houses? And it's most of the community, which is the case with a lot of community boundaries. If I back out to the county, that's actually a little bit easier to see the populated areas. And I did that by just clicking on their breadcrumbs that take you back. Here we go. Now it's refreshing to show us all of Napa County that Calistoga sits in and we can see that we're masked to just populated areas within Napa County, which is a little bit more helpful than just masking out Calistoga. Now I can merge, or I can zoom back in here to the community level and see where there are homes relative to that community. If I wanted to see neighboring counties, I would have to search on those counties. But that feature of just being able to visualize, okay, you're telling me what the risk to homes map looks like, but where are there homes? That was something we wanted to do from the start, and it just took a while to implement. So that is implemented now in the risk to homes view. And then I'll click through some of the other views. So this was our exposure type. If I go back to showing all lands, exposure type was one that basically tells us if a home is located on any place on the landscape, is it going to be directly exposed to wildfire, meaning it's in contact or surrounded by natural vegetation that could burn, or is it indirectly exposed, meaning it's not surrounded by natural vegetation, but it's within a distance of about a mile, or it's not exposed, meaning it's greater than that mile distance from natural vegetation. Here we can see it's all directly or indirectly exposed, but again, we're looking at it across the whole landscape, and so it's really helpful to be able to just focus in on where we actually have homes. Lastly, I'll look at the wildfire likelihood, which is our burn probability, and again, we can choose to look at that masked or unmasked to see the whole landscape or just populated areas. Our vulnerable populations tab didn't change at all. We still have been talking about possible map themes to put in here. Right now it's just a gray background map, and we're really focusing over here on the left side where we're providing some statistics out of the Census Bureau's American Community Survey that gives some demographic information about that community that we've searched. So the big update there, again, to go back to the risk to homes, is that ability to mask populated areas. Let's see. I'm gonna end the demo of the Explore part there. We can certainly talk more about it later. And I'm gonna come back out and just point out then our download page, which, as I mentioned earlier, we can access from the menu bar at any place in the website now. And this is where, if you have the ability to work with raster GIS data and you want to explore these in a little bit more detail for your community, you can go and get any of the 8 raster layers that we published in April, and then we've got another 7 layers that we're working on publishing right now, should be out within the next couple weeks. And so on this page, you can scroll down through and see what's available. And we've got a little thumbnail map that gives you a quick look. So risk to homes, as we just saw, or risk to potential structures, as we call it, in the data publication. If we go to Explore Data, it's going to take us back into the Explore tool, or we can choose to open and download a printable PDF map of that for the US. Burn probability is the wildfire likelihood data that we just looked at. Again, we can explore it, or we can print a map. This is the exposure type that we looked at. And again, we can explore that. We don't have a printable option for that because, as you can see here, it's a map that honestly really doesn't make sense to look at the national scale. It really only makes sense when you're zoomed in to the county or community level. Conditional risk to potential structures, or what we call wildfire consequence, and we saw that on the vertical axis of the scatter plot a minute ago. So this takes probability out of the equation and says, okay, we have a fire in a place. Now, what is the likely consequence of that given wildfire intensity and susceptibility? So again, we can print a map of that. We don't have that in our interactive web application at this time. Conditional flame length tells us something about the intensity. So this is out of the fire modeling. What is the most likely flame length or intensity level that we expect to see at any given place? And that's largely a function of the fuels and the terrain. Again, you can print a map of that. Flame length exceedance probability. This is another way to think about intensity. And so what's the chance of seeing greater than a 4-foot flame length if we have a fire? Or what's the chance of seeing greater than an 8-foot flame length? So again, we can print maps of those. in all of these, you'll notice Research Data Archive is an active hyperlink, and that takes you to the data publication where you can download all of these. The last one in the list there is Wildfire Hazard Potential, and that's one that Jim, Frank, and I have been producing for a number of years at a coarser resolution, 270 meter pixels for the US. And with this project, we decided to go ahead and roll that in and produce a 30 meter version. So again, you can print a map or go to the Research Data Archive. So when I jump out of the demo, I'm going to show you some slides of these data sets here that, as I said, we're working on publishing. And so I won't say too much about those because I'm going to talk more about those with some slides. What I will do is just quickly click on the link to the Research Data Archive. So you can see this is our current data publication with all of those layers that I just highlighted. And it's on the Forest Service Research Data Archive. Again, you get a little rundown of the different data layers. And because they're large 30 meter raster data sets, we have them bundled by state. And they are available if you need the full national data set, but it's about 250 to 300 gigabytes. So basically I have to send you a hard drive. If you want that, I'm happy to do it, but otherwise the data are available for download by state. Okay, I think with that, I'm gonna hop out of my demo and go back to slides and show you some of those data sets that I said are coming soon. So you might have been asking yourself when I showed how you can mask out the populated areas in the website, what we use to base that on. And this is the layer that we use to do that. It's a housing unit density raster that Pyrologics created for us for this project. We intended to just find a data set that we could use and ultimately decided that we felt like none of them quite fit our needs and that we could use data sets that were out there to produce a housing unit density raster that, in our opinion, was more thorough and comprehensive than anything we could find. So for that, we used the 2018 Census Bureau American Community Survey and also their population estimates program. So there are two different ways that the census basically tries to estimate population counts and housing unit counts out from a decennial census. So obviously we have to go all the way back to 2010 as our decennial census starting point. And both of these efforts attempt to project that population and housing unit information forward on an annual basis. So we use the 2018 because that was the most current national data available at the time that we started working on this. And then also the Microsoft building footprints. Lastly, we also used the Landfire fuel model. So another interesting application of Landfire data here, where the fuel models come into play in terms of helping us define what we call habitable land cover. And so that is used in helping to map where houses and people are. And we built largely off of the where people live data set that was used for the West-wide risk assessment effort. Some of you may be familiar with that. So similar methods to that. At any rate, we now have a national housing unit data set. There is data for Alaska and Hawaii. I'll just say that, as you can see, the housing density is quite sparse in Alaska in particular. We also decided, instead of just putting out housing unit density, to also put out population density. We figured that there may be applications for both of these well beyond wildfire risk to communities. And so by publishing these, we hope that people use them for a lot of different purposes. So obviously these are two very closely related companion data sets, but they are a little bit different. So you can either choose to look at the density of homes or the density of people. And a third data set that we decided to create that sort of goes together with those two to, as I put it, create the trifecta of describing the built environment or the developed environment is a percent cover data set that's percent cover of buildings. And for this, we use the Microsoft building footprints and also a USGS building coverage data set that they built off of the building footprints, a previous version. We kind of pulled the best information out of both of those to create this data set that depicts percent cover in terms of area of buildings. Then taking those into some of the data sets that we've already put out, I showed you a minute ago we have exposure type, but really that makes the most sense when you mask it to where we currently have homes. So we decided that we're publishing a version of the exposure type map where we've done that masking. And so this is exposure type where housing unit density is greater than 0. We're also adding in some categories in there, so you can either look at buildings as being directly exposed or not exposed, or 3 categories in between there, because really places that are high in that indirect exposure, meaning they're right next to the directly exposed places, might have different considerations in terms of mitigating their wildfire risk compared to places on the lower end of the spectrum. We take that and we can produce what we're calling housing unit exposure. And so with that, it's wildfire likelihoods, that burn probability times housing unit density. And what that gives us is a metric that can be expressed in terms of annual housing units exposed. You can see from the legend here, those numbers are extremely low, because it's basically what we're doing is FSIM simulates, say, 20,000 to 50,000 years or iterations of a fire season, and it's the annual number of housing units exposed on a pixel level in any given simulation year. So the numbers are quite low, but they give us a relative metric of how much how many houses are exposed to wildfire in any given year, in any given place. The next one is what we're calling housing unit impact. And this is an analog to the wildfire consequences data set that I showed already. Oh, sorry, I didn't mean to skip ahead. With this, I just wanted to reiterate something that is on the website, and I talked about it in a previous webinar, but when we try to describe the susceptibility of a home, obviously we don't have parcel level or home level information for a national scale project like this. Every home is going to have a different level of susceptibility based on the mitigation actions that any given homeowner or community has taken. For our purposes, we have to assume a very generalized concept of susceptibility. And this, what we call response function, quantifies that to where at the different intensity levels, so very low flames on the left, very high flame lengths on the right, we make some gross assumptions about basically the percent of damage that a home might incur at those different intensity levels. That's how we're accounting for susceptibility. And in that wildfire consequence map, it's the intensity out of the fire modeling times these values that give us the wildfire consequence. When we combine that with housing unit density, then we can take that down to just where homes exist. And so that's what we're looking at here. It's an index, which we've chosen to integerize, and to do that, we actually put it on a scale of 0 to 10 million, or to 100 million, in fact. And so this is a third log scale over here. So the point being that the difference from a low class to a high class is orders of magnitude. And this would tell us in any given place, if we have a fire, what's the relative impact to housing? And it incorporates, as you can see from the little icons, intensity, exposure, and susceptibility. And lastly, housing unit risk. And this one, we saw the risk to homes metric a minute ago, is risk to homes essentially, this equation isn't 100% correct, but conceptually it works. It's risk to homes times housing unit density. And so again, it gives us a risk metric that is masked down to just where homes occur. It's an index which we have also integerized and scaled. And you can see that our class breaks again are on a log scale. So the lowest class and the highest class are several orders of magnitude apart from each other. And it incorporates all 4 components of risk that we talked about. So that's a quick rundown of the data that, as I said, we're going to be publishing within the coming weeks here. We would be remiss in doing this webinar at the end of the 2020 fire season to not take a few minutes to talk about this fire season and how did our data do in some of these places where we've had wildfires that have impacted communities. And so we just wanted to take a quick look at a few places around the West. One thing I also wanted to note is that even though we haven't officially published our housing unit density data, about a month ago, Joe Scott with Pyrologics reached out to several online interactive web maps that display information about wildfires, and offered up our housing unit density data because we knew that it would be a valuable addition to those maps. The folks with the Wildfire program out of San Diego State University took us up on it immediately and published housing unit density as a service within their map within a day of getting it from us. So this is a quick look of the Wildfire website showing housing unit density in an area of Northern California. And then if we scan around, these are some screen captures that Joe actually took on September 12th, I think, when a lot of these fires were actively burning. And Wildfire also allows you to look at the satellite heat detections from the VIIRS satellite. So that's what we're looking at here in gray and black, with a little bit of transparency looking down through to housing unit density. So here's the Bear Fire that was near Oroville, California. And we can see looking through that this community of Berry Creek was heavily impacted by wildfire, completely burned over there. Here's the Holiday Farm Fire east of Eugene, Oregon, one of those Western Cascade fires that really is unlike anything we've seen in modern times. And as you can see here, we can see the housing unit density showing population along that river corridor. And in fact, there was damage to homes throughout that corridor as a result of that fire. Another example is the Almeida Fire in Talent, Oregon, Talent and Phoenix, Oregon. And here it is after the fact, looking at the wildfire perimeter from that fire overlaid on top of housing unit density. And you can see just why that fire was so impactful, because it burned really right where homes exist. So taking that and looking at our website, so here's the risk to homes view for Talent, Oregon. And you might notice that Talent and Phoenix and Ashland and Medford all show up as being in relatively low risk to homes area. But a unique thing about this particular fire, it was more or less an urban conflagration and not a wildfire. We can see that the landscape that those communities are set in, so if we look beyond just the community, that there's a fair amount of wildfire risk. So we can infer that, you know, the vegetation there obviously can carry wildfire under the right conditions. And we know that this summer, the conditions under which those fires burned was quite extreme. We can also see this patch of slightly higher vegetation between Phoenix and Talent, which Kelly was explaining to me is a greenway there, where a lot of that fire was able to take hold and spread from. So, you know, our data also point out that just because you're in a low area or an area that may look low in the risk to homes map doesn't mean that you don't have any wildfire risk. And so this is an interesting case that sort of highlights the strengths and weaknesses of our data a little bit. Another interesting case for us this summer was the town of Malden, Washington. It's a small farming community south of Spokane, Washington. And here's a view from Wildfire showing the wildfire perimeter and our housing unit density data. And sadly, the town of Malden was, I think, about 75 to 80% destroyed in this fire. And here's a look at our risk to homes data for that with the wildfire perimeter overlaid. And you can see, sure enough, you know, this is in the Palouse of Western Washington. That's a lot of wheat fields. But Malden sits in a strip of more or less native vegetation that this wind-driven fire was able to blow right through. And so, you know, we felt like our data captured the situation there actually better than we might have expected. And then lastly, going back to the example I showed a minute ago of Calistoga, California, and the glass fire, we can see here what you would see on the website showing the data relative to the state of California, like I showed. And just notice the classes here. It's the lowest class in Calistoga, and then the next highest class around. But actually, if we look at the risk to homes data relative to the entire United States instead of just California, we see that Calistoga actually comes out in a higher class relative to the nation. So this is where sometimes what you see in the web application where it's relativized to state may not be the full answer either. And so it's definitely worth maybe downloading some data, exploring the data in different ways. And I have the perimeter of the glass fire on here, and you can see it definitely burned in places with higher risk to homes. And then here's that risk to homes metric masked out to just communities like you would be able to do in the web application. And so you can see from this that, the places that were in the core of that fire were in the highest classes of risk to homes. Now, we can compare that to HU risk, which is not the same thing. So the HU risk or housing unit risk that we're getting ready to publish is different than just risk to homes. Remember, I said it's multiplied by housing unit density. So when we look at that, here's housing unit risk for that same area, where because we're multiplying by density, we can see these places out in the middle of the fire perimeter show up as a maybe a moderate class because the density of homes in those little bubbles is low. It's isolated homes out in the wildlands, whereas as we get into the outskirts of Santa Rosa, or if we were to get into the core of Calistoga, where housing density is higher, then the cumulative impact or potential for loss from that fire would be quite a bit greater. And that's what we're seeing with the HU risk metric. So, obviously I'm talking a lot about data, and I'm a data person, and we're hopeful that these data sets provide useful information. But obviously I want to just draw back a little bit to recognize that what we're talking about is a real when fires impact communities the way they have this summer. So we see pictures here from Malden and from the Glass Fire and from Talent, Oregon. And these are people's lives and homes that we're talking about. And so it really, it really is something that is extremely important that we wrap our heads around and figure out some solutions to. Kelly included this graph in here to show something that most of us have seen in the news and we're aware of if we're paying attention, that the trend of structures lost to wildfire is definitely on the increase. And this problem is not going to go away. I think we can expect to see these same situations year after year. And so we're hopeful that the data that we're providing, and as Frank said, the conversation that hopefully can be started by our website can at least help to be part of the solution to this growing problem. So a quick note about some additional future improvements that we hope to implement. One is, in addition to being able to search and view at the community and county and state level, we also want to add in the ability to search for community zones that show surrounding area around any given community. We also want to include the ability to change your comparison options. And so like I just showed a minute ago, the risk to homes map looks different if you look at it relativized to your state versus relativized to the country. We want to provide that as an option within our web viewer so people can change their comparison options. Same with the scatter plots that you see. Do you want to compare your community to other communities in your state, or do you want to see how you stack up to a representative sample of communities from across the country? And then lastly, as Frank alluded to earlier, as the Landfire remap data are completed here, we're already talking about getting FSIM spooled up and running that on the latest Landfire, which will be Landfire 2016 rather than Landfire 2014. So that will produce a whole new set of hazard data, the burn probability and intensity data that we use. And so when we have that, we'll update these metrics. And then also, obviously, we're heading into the 2020 census here. And so when new census data are available again, we hope to update our information. And with that, I'm going to take a deep breath. And I think we can open it up for questions. Looks like we've left ourselves about 20 minutes.
Yes. Thank you, Greg. We do have about 20 minutes, so we've been sort of monitoring the questions in the Q&A, and Kelly has a couple that she's going to tackle first.
Thanks. Yeah, and I'm probably going to toss most of these to Greg and to Frank. First, Greg, do you want to just address a little bit about how the fuel models take into account climate and whether climate change is incorporated into the modeling?
Sure. So really, Frank kind of gave the answer to this earlier in saying that we don't incorporate climate change science into what we're doing here. The fuel models are representative of conditions at the time they were mapped. So, what we're looking at here are based on 2014 fuel models, ground condition. What we're hoping to update to soon is 2016 ground condition. And our calibration of our fire modeling, the FSIM modeling, basically looks at averages from observations in the last 20 years or so. One way that future modeling efforts and maybe our next round of modeling might start to incorporate at least the concept of climate change is that those FSIM calibrations, instead of being calibrated to, say, average values from what we've seen over the last 20 years, we can actually plot out trend lines in some of the wildfire metrics like annual average area burn and things like that. And instead of calibrating to the average of what's been observed, we can calibrate to where we expect to be now or 10 years from now on those trend lines. That's something that's still kind of experimental, but something we've talked about.
Thanks, Greg. Edith also asked if there are liaisons that people can talk to in order to get an idea of how to use these data in conjunction with state level mapping or other local or regional resources. And so I just want to point out that all of our email addresses are here on the screen, and we're always available to talk about ways these data can be used and point you to other resources. So please don't hesitate to reach out. There's also a web form on the website that goes to real people. So if you put a question up on the website, we do respond to those and delegate those questions out to the appropriate people on the team to respond to. Greg, there's a bunch of questions here from several people about home-to-home ignition and whether how embers are incorporated into the modeling, first of all, and then second of all, whether home-to-home ignitions are considered. And so maybe can you just discuss that briefly?
Yeah. So the science around what happens when a wildfire transitions from being a wildfire to being an urban fire is very much outside of what we're able to represent with our fire modeling. Our fire models are wildland fire models. And when a fire gets into a community, that becomes, a structural fire, a fire engineering problem. And we're definitely engaged with people. I know Dan Gorham, I saw you sign in at the beginning, and Michael Gallner, and a number of people who are doing that kind of research. That is not directly incorporated into what we present here. What we did was understanding that what we get out of FSIM stops at the boundary between wildland fuel and a community. Pyrologics came up with a way to just use some spatial analysis in GIS to smooth the characteristics of wildfire, burn probability and intensity probabilities into the community. And we chose a distance of up to about a mile. And so that's recognizing some of the science that's been done on how far away from that wildland fuel edge do we tend to see home losses. I want to say something like 85 to 90% of all home losses tend to be within a mile of wildland vegetation. And so that's where that comes from. This year may change that number. We saw spotting distances of a lot more than that in some of those, especially the west side fires on the Cascades and in California. So that's how we're able to incorporate it. I will say that one interesting observation that Joe Scott with Pyrologics had when we created that building percent cover raster that we're getting ready to publish is that you can look at these places that have had high degree of home-to-home ignitions, Paradise, Talent, and they all tend to have above a certain threshold in that building cover layer. Basically from that you can infer that if you have your percent area of building is above some level, that implies a density of buildings great enough to facilitate that home-to-home ignition. So again, that's just sort of a casual anecdotal observation, but that's that's what I can say about that one.
And to sort of piggyback on that, Carrie asked if you know of examples of other tools that can be incorporated, maybe at the local level. Are there ways that people can take these data and models we've built and factor in that home-to-home ignition? And then there's also a question about severity and whether these data can help provide a picture of the damage that can occur and sort of the severity of impact.
Sure. Repeat, what was the first part of that question again, Kelly?
Sorry, I'm conflating two questions here.
Okay.
Are there ways that people can take these data and use them locally to think about home-to-home ignition?
Right. So that one, I mean, you absolutely can take these data and apply them in local analyses. In terms of incorporating home-to-home ignition, I don't know. I'd be really interested to talk with people about that and see if people have ideas. We certainly cite a lot of science on our website, and this is making me realize I don't know that we cite a whole lot of science specific to the urban environment, the home ignition problem, the home-to-home ignition problem. And so I guess I don't have great insight on exactly how you would incorporate that. You could, our methods for how we use spatial analysis to smooth those fire behavior outputs, that is certainly in the documentation we have with our data publication. So you can read that and see, maybe take the same approach, but if you feel that a mile isn't far enough for your area, you could, do a greater distance than that. And then the second part of the question, Kelly, sorry, I'm having a hard time remembering.
No, that's fine. The second part of the question was about severity and how you can infer the severity of impact to a structure, the kind of damage in the built environment.
Sure. So that gets at that housing unit impact raster or conditional rasters that I talked about that do show that. And so yeah, in terms of severity to the built environment, those can help you get a sense of that. Understanding that we have taken that very sort of crude, generalized approach of quantifying the impact of fire on a home. And so for communities that have parcel level or home level wildfire assessments where you have rated out the susceptibility of individual homes, you could combine that with our wildfire likelihood data and our intensity data to get maybe a more realistic picture at the local level. So yeah, that would definitely be something you could do with the data at a local level.
Great. There was a question in the chat about what kinds of structures are included in the data, just residences or other kinds of buildings. And then another question about whether we plan to look at transportation vulnerabilities and the transportation network.
Okay. In terms of what we call a home, basically we use a combination of locations from the Microsoft Building Footprint data and the census data to tell us basically what is the population within any given census block, and then how do we distribute that to point locations that we can identify as being homes. Now, if we can identify buildings as being non-residential, meaning that there's no population associated with them, then they are excluded from what we call a housing unit. But what we do include as a housing unit includes anything that has census population data associated with it. So that's going to include houses, apartments, apartment buildings, nursing facilities, prisons. Prisons are a big one. Housing density at prison locations is extremely high. And in fact, that's one sort of odd little fact about our data that incorporate housing unit density. The HU risk, for example, has its highest point at a prison because it has the highest housing density combined with a very high, general wildfire risk. University campuses, military barracks, all that kind of stuff that is associated with population is what we incorporate as housing units. And as far as transportation infrastructure, no, we don't currently have any plans for that. Not to say we couldn't in the future, but right now our focus is homes.
Thanks, Greg. And I just want to point out also that we are planning at least one, if not two, additional updates in 2021. And we're working right now through sort of our priority list of what to include in those updates, but we're really eager to hear from users and to understand what you all feel is missing or what could be enhanced. We can't make any promises that it's possible to execute your wish list, but we want to know what's on your wish list to help us improve the site over the next year. So you could share that feedback with us here today. You can email any of us or reach out to us via the website. We really want to hear from you about your hopes for what this site can offer.
Thanks, Kelly. I totally agree. Yeah, let us know how it's being used, what you find useful, what isn't useful. We'll pass that on up to agency leadership, and it'll filter its way up to Congress, which originally asked that this site be created. And yeah, I think they'll continue funding it if they understand that people are using it and finding it useful. If I could maybe piggyback on some of the stuff Greg said, I'm not a modeler, so my understanding of this is a little bit simplistic. But yeah, we had a uniform response index of what happens when fire encounters a house at different fire intensities. But if you have information about your local housing, that some houses have taken mitigative actions and have reduced their ignitability within the home ignition zone, yeah, and you can change that susceptibility rating for those houses, that would be something you could do locally. There was a question about the weather and whether we're predicting climate change. We're using weather readings from the last 20 to 40 years at weather stations across the nation, and then put into a gridded format in the large fire simulator. But I know of one researcher who's looking at that, and then the actual weather that's used when the simulator goes is randomly selected. So all the weather that occurred at that spot on July 15th, it'll randomly select one of those 40 incidences and say, this is the weather in this simulation. And then in the Monte Carlo simulation, it'll go over 20 or 30,000 times to see what the likelihood is. But I know one researcher who's saying, well, what if instead of using all the weather that happened, I only look at the 10% of the worst days? Is that a climate change simulation? Well, maybe. And so he's experimenting with only looking at those worst burn days and only having those to be selected from when you do the Monte Carlo simulation. So that's interesting. We're keeping an eye on that, but it's still pretty experimental. And then maybe one other idea. Some of the fires we saw this summer in 2020 were what I consider a low probability, high risk, particularly those west of the Cascades. It's something that may only happen once every 100 years, but once it happens, there's a high potential to have home loss. And so this is where that additional index that Greg talked about, once the fire is already started, you can analyze the risk of having that fire. And Greg talked to me about this, I don't know, 2 weeks ago, and it really struck a chord. He said, this is a low probability that we're going to see a big fire on the west side of the Cascades, but it does happen occasionally. And when we do, where are the risks going to be? And here he's pulled up a map of 4 big fires in Western Oregon, I think. You want to talk about that, Greg?
Yeah. It's like you knew I had these, Frank. So yeah, I mean, I made these because I thought it might be an interesting discussion point if we had time. But as Frank said, I mean, those Western Cascade fires, we have, if you look at the tree ring record, we have seen fires like that in the Western Cascades in the past, but you have to go back hundreds of years to find them. This is the HU risk that incorporates burn probability with some of those big Western Cascade fires. And you can see just from the general colors that the risk is much greater on the east side of the Cascades with Bend and Sisters and Redmond than it is over on the west side of the Cascades in the Willamette Valley. But if we look at the impact raster that I talked about, where this is conditional on there being a fire, now you can see actually the colors on the west side and the east side look very similar, meaning that if a fire happens to get into these communities, the consequences or the impact can be just as great as it is in the places with a higher burn probability. It's just that it's very difficult for us to predict the low probability events and have them show up in the risk metrics that incorporate probability.
So I just want to jump in here real fast. I think Greg, Kelly, you guys did, and Frank, you did an excellent job of presenting it. This presentation was obviously very data heavy with the new data and the new science behind it and the products. But I also encourage you to really explore the other parts of the website. The reduce risk section has a lot of valuable information, especially for non-data people. And the idea of that information being helpful to maybe start conversations on what actions can be taken on the ground from the homeowner all the way out to land use planning and those things. But this did an excellent job of covering the data components and future data coming. And considering the target audience, it's a perfect fit. But some of the other parts of the website might be valuable to some of your partners, local community members, county commissioners, those things. So please explore that and share that. And again, as I said earlier, if you have any questions, this group is incredibly responsive to answering questions. So you can either post them or contact them directly. Thank you for taking the time.
Thanks for bringing that up, Jim. We've hosted a couple other WRC webinars. I think one was like intro, what is this website? So check out our YouTube channel and you can find those on our YouTube channel and probably hosted on your guys' website as well. So with that, I'm going to say thank you so much for joining us today. If you haven't taken the poll, please take a second to do that. It helps us know if we're doing our job well. And I'd like to say to be continued, because we've generated a great partnership with the WRC team, and we'll be hosting another webinar, I think early 2021, to talk a little bit more about this project. So I think we'll just organically unfold this as time goes on, because it's a very exciting time for this field, and I'm really glad to be a part of it. So thank you, Greg. Thank you, Kelly. Thanks, Frank. Thanks, Jim. And thank you to the over 60 people that joined us today. It was wonderful to have you all, and more soon. So have a wonderful day, everybody.
Thank you, Megan.
Thanks.
Thanks.